Hi guys, today we will be talking about 1.6. So 1.6, it's a way to take derivatives more easily. So the topic for this, or the name of this, is some rules for differentiation. Ooh. Okay, so the nice thing, I know how much you all loved doing the derivative using the definition. Um, so remember that the definition of our derivative, right? Remember what the derivative is. The derivative gives us the slope of the tangent line at a point x. Oops, sorry about that. So remember, this is the definition of the derivative, right? So in that last section, if you needed to take the derivative, we actually had to go through, all of this stuff here. And I love algebra just as much as the next guy, but it got a little bit difficult. So as you saw in 1.6, we had some rules for differentiation. So I just want to write those down really quick. I know you probably already have these in your notes, but in case you don't yet, these are very important to have in your notes. So let's write down the differentiation rules. So the first rule that we're going to have is that the derivative of a constant is 0. This makes sense. Remember what the derivative means. The derivative means you have a rate of change, right? The derivative tells you how quickly something is increasing or decreasing at a moment in time. And if we have a constant, well, what's the derivative of a constant? It would be 0. It's not changing. It is constant. That's why we call it a constant. Another differentiation rule, and I'm going to kind of combine some stuff. If I have some constant k times my function, then I can just pull that constant out and then just take the derivative of the function, which is pretty great. This is a nice one to know. So if I know, well, we'll do some examples here, but like if I know that the derivative of x is 1 maybe, which maybe you didn't know that, but it is. If I look at the graph of x, right, that is just a line with slope 1, then that's really just 3 times the derivative of x. So that's all that's saying right there, is that I can just pull out that constant, okay? So we'll just put that on the side there. 3, so if I have two functions added or subtracted together, so I'm just going to put f of x plus or minus g of x. So this means I can add them or I can subtract them then to take the derivative of that. And remember, that's what that d dx is. Then what do I get? I get f prime of x plus g prime of x. Okay, so, or minus, depending on if it's addition or subtraction. So, if I had, well, we're going to do a lot of examples of this. I'm just, if I had 3x plus 4 and I wanted to take the derivative of that, I would take the derivative of 3x, then I would take the derivative of 4, and then I would add those together. That's what that guy's saying right there. This is the one that we are going to use the most. So this is called the power rule. And this is if I have x raised to any constant, so say r, we'll let r be a constant. The power rule says we'll take r times x, and then we have r minus 1. So this power rule is a big deal, okay? So this power rule is something that we are going to use all the time. This again is called the power rule. We are going to use this all the time to take derivatives. Now, we will be using, like 3 and 2 and 1 as well, but these guys won't be as obvious. Like it'll be more used, but maybe you don't really realize that you're using it. So if I have x to the r, the power rule says I bring the exponent down in front and I take 1 away, and that's the derivative. Look at how much easier this is now than having to use the definition of the derivative, right? But it really makes you appreciate, this is what I tell my students, it really, going through all of this up here, really makes you appreciate, whoa, what's going down with our new rules. So this is a pretty big deal. So again, instead of taking, if I want to take the derivative of x squared, instead of putting in x plus h and foiling that out and taking the limit as h goes to 0, now I can just bring the 2 down, take 1 away, and I know the derivative is just 2x. And then the last one, I don't really love that your book brings this rule in, but I kind of understand why they do it, because without it, you know, we're kind of limited in the functions we can take the derivatives of, and that's fine. I'll get over it. I don't really like this, because we can't really prove this for you, or they don't prove it for you yet, but they will prove this for you later on in the book, and I'm sure you will be waiting eagerly to see that proof. So this is what we call the general power rule. So notice on 4, we were taking the derivative of just x raised to an exponent. Now, if you notice, we have a function raised to an exponent. So what I want to do, this is called the general power rule, is again, you act like the inside is just an x. You bring the r down, take 1 away, and then just leave that inside as it is. But with the general power rule, what you need to multiply by, and we're going to do a bunch of examples with this, is you need to multiply by the derivative of the inside. Okay, let me really quick get rid of some of this. Okay, so you gotta multiply by the derivative of the inside, and that's something that you cannot forget when you're doing so this again is called the general. I know I'm just supposed to be really doing examples for you, but sometimes I can't help doing a little bit of a lecture. So you're going to have a little bit of a longer video probably. So these are very, very important. We will be using these the rest of the semester. This is going to involve something we call the chain rule to prove it, but the chain rule we'll get to eventually. But these are the big ones. So I would say, you know, of all of them, 4 and 5 are the biggest ones that you need to know. These 3 up here are very important as well, but you kind of end up just using them as you go through. So it's not as big of a deal. These 4 and 5 are quite new. But, you know, 1, 2, and 3 are similar to maybe what we would do. Well, I guess the constant being a 0 is pretty important. So, all right. So let's look at some examples. So let's find the derivative of the following functions. Remembering, what does the derivative give us? It gives a slope of the tangent line. We do not have to, let me finish writing. We do not have to anymore estimate what that slope. Remember in 1.2, I think we just estimated the slope of all those lines. We don't have to do that anymore. So let's do a couple examples. I just want to start off pretty easy. I don't want to do anything too crazy here. So let's look at f of x equals x cubed plus x squared minus x plus 4. I know that maybe that doesn't seem super simple, but for now, so let's look at this and let's think about what we're going to use for this. So if you look at back to what we had here, what differentiation rules are we going to use? So I definitely am going to use number 3, right? Because I'm adding a bunch of functions together. I'm going to be using this constant rule because I have a constant at the end, and then 4. So I'm going to be using 1, 3, and 4 on this one. Okay, so let's go ahead and do that. So f prime of x then. What does the power rule say? That power comes down in front. So this is going to be 3x, and then I take 1 away from the exponent. Oh, I have no idea why I did a negative. Okay, so that should be 3x squared. Same thing with x squared. I'm going to bring the 2 down. I'm going to take 1 away, so I could put 2x to the first power, but I'm not going to worry about that too much because that would just be x. And then let's think about what happens here. Remember, that's x to the 1 right here. And remember this constant, and well, with the subtraction, I can just bring that. I'm going to show you this one, and then I'm not going to do this every time we're going to make that to the 0, and then of course the 4 goes to 0. I'm showing every single step here. You don't need to show every single step, but you know, show me some of your work here, especially as you just start using these rules and get used to them. And so of course my final answer, I want to make sure x to the 0. What is x to the 0? That's just 1. Remember, anything to the 0 power is 1. And so my final answer here is 3x squared plus 2x minus 1. Okay, that is the derivative. So like if I wanted to know, you know, I have this cubic function. I don't know what it looks like. Whoa. But I have a cubic function maybe that does something like, this is a lot harder to do than on a, maybe it does something like this. right? And what does that derivative mean? Well, if I want to know the slope of the tangent line at whatever x value I want, so maybe I want the slope of the tangent line at 0. Well, if I put f prime of 0, look at what I would get. I would get -1, so that tells me that, oh, that's actually not too bad. If I look at the tangent line here, okay, that slope is -1. And I can do that with any of the points on this graph right here. If I wanted the slope at 1, I would just plug in 1 to this. If I wanted the slope at 2, I would plug in 2 into my derivative. That is what the derivative gives you. The derivative gives you the slope of the tangent line at whatever x value you want. All right, let's look at a couple more. So what about f of x equals, how about 4 times the square root of x? So when you're doing these 4 times the square root of x, what I want to use is my power rule. So right away what I'm going to do, especially when you have anything with a radical, is you want to rewrite it. So remember that the square root is also, we can write that as an exponent. We can make that x to the 1/2. So to take that derivative, we'd have f prime of x then is 4. Remember, the constant can come out, and then I can take the derivative of x to the 1/2. That was our number 2 rule, that I can bring the constant out, and then I'm going to take the derivative of x to the 1/2. So I'm going to bring the 1/2 down, and then remember, what am I going to do? What does the power rule tell me to do? It tells me to subtract 1/2 from whatever my exponent is here. Or, oh no, not 1/2. Oh, are you yelling at the screen? Subtract 1. So if I subtract 1, 1/2 minus 1, right, is, oh, Sarah, come on. 1/2 minus 1 is a -1/2. Oh, so let's simplify this. I do not want that as your answer. I need everything simplified. So what is my answer? 2x to the -1/2. You can leave it like that. I am fine with you leaving like that at this stage. We will want to rewrite that later on. But I could also write this as 2 over x to the 1/2. Remember, that's what a negative does. Or I could even write this as 2 over the square root of x. This would probably be what I would write as my final answer. We're going to be doing some stuff with the derivative later on where it might be useful for us to write it as a fraction like that. Let's keep going. So let's try another one. Just going to clear this out really quick. So I think we're on C now, correct? Oh, my brush size went way up. Okay, so C. So what if we had, oh, that's a little darker, sorry. What if we had something with fractions? So part C, what if we had f of x maybe equals, I don't know, how about 1 over 2x? Okay, and I want to take the derivative of 1 over 2x. So again, what I want to look at is I want to figure out how to rewrite this in a way that allows me to use the power rule. So remember, the power rule involves something like x to the r. So that's what I need to figure out here. So I need to do something like x to the r, but to be able to do that, I need to do a little bit of algebra and I need to rewrite this. So look at what this is. This is really just 1/2 times 1 over x. You would agree with that, right? So how I rewrite this then is 1/2 x to the -1. You may not bring the 2 up with it. That 2 is not being raised to the -1 power. And so now that I've rewritten it like this, I am able to take the derivative using my power rule. Again, 1/2 times, there's my constant. I would bring the -1 down, x, take 1 away. That would be a -2. And then if I simplify this, I get a -1/2 x to the -2. Or if you wanted to put that on the bottom, you could get a -1 over 2x squared, and you can call that good. Now notice what ends up happening, I mean on all of these, what happens to that exponent? When it comes down, all it really does is multiply times that constant in front. Notice how I keep combining those two and multiplying them. So I just want you to realize that that's really all that happens. You sure can just go ahead, you could have gone straight to this step if you had wanted to. Let's try another one. That was kind of fun. So let's look at, there we go, that's a little brighter. I changed the setting. I don't know how I did that. How about something like, well, let's look at the general power rule. So what if I had x squared minus 1 all cubed? So remember, if I wanted to take the derivative of this with the definition, I would have to put in that x plus h. I'd have to FOIL it out. I'd have to actually cube it. I would never do that to you, something like that, because I don't want to grade it. It's a total selfish thing. So let's remember let's go back and look at what the general power rule told us. So the general power rule, right, says that if I have an inside function raised to an exponent, I basically do the power rule. I bring the exponent down, take one away, but then I multiply by the derivative of the inside. So let's do that. Okay, so f prime of x then, whoops. So f prime of x, remember you should, oh wow, sorry about that. You should be putting a primed when you go to take the derivative. So f primed of x then. I'm going to bring the 3 down, right? So my general power rule says to bring the 3 down. I just leave the inside. That's what that g of x is. I take 1 away. So I took 1 away, and now I multiply by the derivative of the inside. This is the general power rule. Okay, later on we're going to see it's something called the chain rule. And then you need to simplify this. So this 2 and this 3 can be multiplied, and I usually like to put my x in front. So my simplification is this. And you know, if you cannot sleep at night with that x squared minus 1 not being factored, you can factor that, but there's no reason to factor it because for right now we're not trying to solve an equation involving the derivative. I hope this is making sense. Let's just do one more really quick. Oh, I need to get back to. Let's just do, what if I had let's look at, I don't even always have to have f, so let's look at g of x equals, I don't know, how about x over, no, let's do x squared plus x all over, how about the cubed root, ooh, this will be fun, of x, okay? So I want to take the derivative of x squared plus x all over the cube root of x. So what I want to use again is I want to use the power rule. This is going to be a lot like C up here. I want to rewrite this using my exponents, and then I'm going to simplify. So what I'm going to do is I'm just going to rewrite the top as x squared plus x. I'm going to put this to the first power just for the fun of it. And then on the bottom, I'm going to rewrite this as x to the negative 1/3, because this is the cube root, right? So the bottom is x to the 1/3, and then I moved it up on top, so that's x to the negative 1/3. Let me caution you right here. You may not take derivatives across multiplication. This is multiplication, right? You may not take the derivative of this and multiply by the derivative of this. If you look at your rules of differentiation, that is not one of the rules. So what I need to do is I need to distribute this to each term, right? That's what I need to do. So I haven't actually done any calculus yet. All I've done so far is algebra. 2 minus 1/3, well, that's 6/3 minus 1/3, which is 5/3. And remember, we're adding exponents. Oh, I need a plus sign in between there. And then 1 minus 1/3, well, that would just give me 2/3, okay? Now I'm ready to take the derivative. So again, notice I have not actually done any calculus. All I have done is the algebra. I had an advisor in school tell me that it's not, when I was teaching calculus as a graduate student, it is not the calculus that's hard. I mean, these rules are pretty simple. You know what's hard? It's the algebra. And so if you're having trouble with the algebra, you need to let me know. And we can get together, we can talk online, we have Jabber, we could chat online during my office hours, or we can talk on the phone. Okay, I'm ready to take the derivative. So I'm going to take this guy, I'm going to bring it in front, and I'm going to take 1 away. So this would be 5/3 x. 5/3 minus 1 is 2/3. Get a common denominator. I should not have to show you how to do that. These are fractions. I know fractions can be scary. Or use your calculator, and there's my final answer. Okay, I know we're almost to 20 minutes, and I'm probably losing your interest, but I want to do one more really fast. Losing your interest? No way. How do you lose interest when it comes to calculus? Calculus is just so great. I just love it. It's fun. It's useful. It's interesting. Okay, so here's a brand new example. What I would like us to do is find, last example, and then I'll stop talking. The equation of the tangent line to the curve, or to the graph of y equals, let's say 3x squared minus 2x plus 4. And now I need to tell you at a specific point. So let's do this at the point 1, 5. Okay? Find the equation of the tangent line to the curve at 1, 5. So what do we need to find the equation of a line? We need slope, right, and a point. Well, lucky for us, we have a point. And now to find the slope, what do we need to do? We need to take the derivative of this guy. So let's do that. So y primed, that's another way to say the derivative, or you could also say notation, this is dy dx, either one will work. Y primed or dy dx, let's take the derivative of this guy. So again, I'm going to bring the 2 down, I'm going to do the power rule. The 2 will come down and multiply by the 3, so that's 6. Take 1 away, it's just 1. So that's 6x. With the 1 here, I'm going to bring the 1 down and multiply it by the 2. So that'd be minus 2. Take 1 away. That'd be 0. X to the 0 is 1. And then the 4 goes to 0. So look at what I have here. I have the derivative of the function right at any x value. Well, what is the x value I care about? I care about when x is 1. So I'm going to take y prime of 1, and this will give me the slope, people. This is the slope of the tangent line. So that is 4. That is my slope. And what does this equation want? It wants you to find the equation of the example wants you to find the equation of the tangent line to this curve. So now I can put this into point slope form. I'm just going to take y minus 5. You guys did a nice job with this on your homework. Equals 4 times x minus 1. You are welcome to leave it just like that, people. Or if you cannot sleep at night, I know some of you will not be able to, you are welcome to put it in slope intercept form. So I will take either one of these as your answer. If you have any questions about this stuff, please contact me and let me know.